Hai guys, Assalamualaikum. So kita akan sambung topik kita iaitu Hess's Law. So Hess's Law state that in chemical reaction, change in enthalpy is the same whether the reaction take one step or more than one step. So madam ambil contoh lah. Let's say kita nak daki gunung Kilimanjaro. Gunung Kilimanjaro. So, let's say lah ada dua path. You boleh lalu jalan X, satu lagi you boleh lalu jalan Y. So, tak kisah you nak lalu jalan X ataupun jalan Y. Kenapa? Sebab enthalpy change dia sama sahaja. So walaupun yang ni nampak macam jauh, tetapi sebenarnya bila kita kira-kira, enthalpy change dia sama. So itu adalah Hess's Law. So patah balik pada kita punya reaction lah. Let's say kita punya main equation adalah A jadi B. So untuk dapatkan enthalpy change, kita boleh cari dulu enthalpy change of A become C. And C becomes B. So, if we want to find out delta H1, kita boleh tambah delta H3 and delta H2. So delta H for the overall process equals to the sum of all the components. So, if we want to find out this enthalpy change, so kita boleh tambah enthalpy change yang lain. So, this is the formula. Delta H1 equals to delta H2 plus delta H3. Kita tengok pada real equation lah. For example, dissolution process. So, the formula for dissolution process is enthalpy of solution equals to lattice energy plus enthalpy of hydration. Madam ambil contoh sodium chloride lah. So sodium chloride, when sodium chloride solid become ion, aqueous ion, proses ini adalah solution. Ingat balik enthalpy of solution punya definition, di mana substance is turned into, the substance here turns into aqueous ion. So this is enthalpy of solution. So next. So if the substance change into gaseous ion, so this is what we call lattice energy. Madam tambah sini. This is lattice energy. Lattice energy adalah proses di mana substance turns into gaseous ion. Next, cuba tengok. Gaseous ion become aqueous ion. So the process is hydration. So I repeat. If gaseous ion become aqueous ion, the process is hydration. So if we want to find out how much enthalpy of the solution, so kita boleh tambah lattice energy plus enthalpy of hydration. So that's the concept of Hess's Law lah. Kita proceed. Ada dua cara untuk kita dapatkan enthalpy change. Untuk kita kira enthalpy change. The first one is by using energy cycle method. So for energy cycle method, madam pergi terus pada practice question. So based on the data below, the question gave you enthalpy of hydration, enthalpy of solution. Jangan panik. Tengok dulu dia nak apa. Construct energy cycle diagram and calculate lattice energy. Calculate lattice energy. So, if the question wants you to find out lattice energy, remember the formula, this formula. Enthalpy of solution Okay, enthalpy of solution. Let me write down for you. Enthalpy of solution equals to lattice energy plus enthalpy of hydration. So, nak buat apa? Kita buat dulu equation untuk enthalpy of the solution of sodium chloride. Okay, kalau enthalpy of solution, sodium chloride substance, okay, solid, dia akan jadi aqueous ion. So, kita ceraikan dia jadi ion. Ingat balik kita punya thermochemical equation. So, basically, this is standard enthalpy of solution, which is, dia dah bagi value 6 kilojoule per mole. Okay, so that's the equation lah. Okay, next. Tengok balik. Next, lattice energy adalah proses di mana substance turn into gases ion. So, this substance, okay, kita buat anak panah ke bawah, turns into gases ion. So, dia adalah ionic solid kan? So, sodium plus gas plus Cl minus gas. Okay, the process is lattice. This process is called lattice energy, and this is what we want to find out. Okay, next. Gases ion turn to aqueous ion. Okay, kalau kita tengok kat sini, dia bagi satu-satu for sodium and another one for Cl minus. So enthalpy of hydration untuk Na, okay, madam tak cukup ruang, so madam terus letak dia punya value lah ya. Okay, negative 390 kilojoule per mole. So that's the value. So for gases ion turns to aqueous ion. Okay, for chlorine minus, the value is negative 380 kilojoule per mole. Okay, so cuba awak tengok Hess's law ni. Okay, so the reaction can take one step or a series of steps. Okay, so anak panah mestilah menuju ke arah produk. Okay, now enthalpy of solution kita adalah 6 kilojoule. 6 equals to lattice energy, that is what we want to find out, plus negative 390 plus negative 380. Okay, perlu kembang tak kilojoule per mole tu? My advice is you don't have to lah. Okay, so here you should get 776 kilojoule per mole. So that is the lattice energy lah. Okay, so we follow this formula. Okay, tapi soalan suruh construct energy cycle diagram. So this is how we construct the energy cycle diagram lah. Okay, next we try on the next one. The reaction for the formation of 18 is stated as here. Based on the data below, calculate enthalpy of formation of 18. So dia nak enthalpy of formation of 18. So first, you tulis dulu your target. Kita punya target equation adalah equation formation of 18. Okay, so soalan dah bagi dah. Kadang-kadang soalan tak bagi tau kita punya target equation. So basically, this is what we want to find out. Okay, tapi data dia bagi untuk ketiga-tiga inilah. So kita nak buat macam mana? Okay, for this one, kita buat satu demi satu. Kita tengok dulu untuk karbon. Okay, kita tengok carbon, so kita cari equation yang ada carbon. However, here, carbon 1 mol. Dekat sini carbon 2 mol kan? So, everything here, we times with 2. So, ingat balik kita punya rules kan? Bila kita darab 2, ke semua ni nanti darab 2 dan value ni pun nanti double. Okay, so how to do the energy cycle? So first, kita tulis anak panah ke bawah. Okay. Cuba tengok equation pertama. Okay, equation pertama. The product is CO2. So kita tulis dulu dia punya product. Tapi kita sudah darab 2 kan? So CO2 gas. Okay, dekat sini, dekat anak panah ni, you tulis plus 2H2. Okay. Okay, that's it. Okay, the value, okay, 393, negatif 393.5 darab 2. So here, you should get negative 787 kilojoule. Okay, that's the value given. Okay, so settle the first one. Next, we move on to the next one. Kita nak tengok hydrogen pula. So, kita cari equation yang ada hydrogen. So, the second equation. Okay, so as you can see, for the second equation, hydrogen dia macam tadi, 1 mol. Tapi kat sini 2 mol. So, everything here, we times by 2. So, ke semua sini, kita darab 2. Okay, so now it's time to construct the energy cycle. 2H2. Okay, kita tengok produk dia dulu. Produk dia adalah H2O. So, bila darab 2, 2H2O. Okay, here, bila kita darab 2, dia akan jadi oksigen sajalah kan? So, plus O2 gas. Okay, so next, the value. The value given original is 285.8 kan? So, we times with 2. So, you should get negative 571.6 kilojoule. So, settle the second equation. Next, cuba kita tengok. Next, we are going to add these two, 2CO2 plus 2H2O. Okay, produce C2H4. Ada tak equation tu? Ada, iaitu equation ketiga. Cumanya, okay, madam nak minta you guys betulkan sikit. Kat sini sepatutnya ada 2H2O. Okay. Cumanya, kita punya energy cycle, for our energy cycle, our carbon dioxide and water adalah reactant. Tapi dekat sini yang dia bagi, these two are product. So what happened? We are going to reverse. We are going to reverse the equation lah. Bila kita reverse equation, okay, the value akan jadi positive. Ingat balik kita punya rules untuk thermochemical equation tu. Okay, so this one settle. Okay, if you ask me, madam, yang ni kita nak tulis kat mana? Okay, untuk oksigen, kita anggap saja dia sebagai side product. Okay, tak tulis pun tak apa. Yang kita punya main concern is this 3. Okay, so in order energy cycle diagram ni, untuk dapatkan cycle tu, you have to adjust the, how do I say, adjust the equation. Okay. So next, dah settle energy cycle, kita nak cari what is the enthalpy of formation here. So kita tahulah kalau ikutkan Hess's law, delta HF equals to negative 787 plus negative 571.6 plus 1411.2 kilojoule. Okay, so for this one, negative 787 minus 571.6 plus 1411.2. So you should get positive 52.6 kilojoule. Okay, so the concept is yang awak nak cari, this is what you want to find out, equals to the sum of all the enthalpy change. Okay, this one equals to hasil tambah all these three. Okay, kat mana kita dapat ni? Kita dapat ni daripada equation dekat atas. Okay guys, so that's the energy cycle diagram. Okay, so now let's go to the second method. Okay, for me this one is more simple lah compared to the energy cycle. Okay, so for algebraic method, okay, madam terus pergi pada equation lah ya, practice question. Okay, so question 1. Dia bagi enthalpy of thermochemical reaction for 3 reaction. So question wants you to find out enthalpy of formation for ethane. Okay, so dia tak ada bagi dalam, dia tidak ada bagi dalam apa namanya equation. So you have to write down on your own. Sebab tu penting you faham enthalpy tu. Okay, so let's do this together. So we want to find out enthalpy of formation of ethene. Formation, kita ingat balik, recap balik, is made up from element. So ethane ada 2 elemen, elemen carbon and also element hydrogen. Carbon exists as solid, hydrogen exists as gas lah. So let's balance the equation. This one 2, this one 3 lah. So basically, this is what we want to find out, enthalpy of formation. So letak sini sebagai kita punya target equation lah. So what you have to do is, algebraic method ni, kita kena alter these 3 equation supaya kita dapat equation target. Okay, for example, here, let's start from left-hand side. So here we have 2 carbon. So kita cari dalam banyak-banyak equation ni, yang mana ada 2 carbon. Okay, so madam jumpa carbon kat sini, tapi ada 1 carbon kan? Okay, so kita kena everything here we times with 2. Kenapa? Sebab kita nak follow target equation. So, kita tulis balik 2 carbon plus 2 oxygen. Bila kita tulis balik tu, mestilah tulis bersama-sama dengan phase dia. Okay, so enthalpy change dia sudah berubah lah sebab kita dah darab 2. So, here you should get negative 786 kilojoule. Okay, settle the first one. Okay, next kita punya target adalah 3H2. Okay, 3H2. So 3H2 kita boleh dapat dekat equation ke-2. So kita kena darab dengan 3 lah supaya kita dapat 3H2. So we salin balik 3H2 plus 3 darab 1/2, you akan dapat 3/2 O2. Okay. Yang ni akan jadi 3H2O. Okay, delta H dia, you kena darab 3 lah. Okay, which is negative 858 kilojoule. Sebab kita darab 3. Okay, last one. Target adalah C2H6. Okay, kita ada C2H6. Tapi target kita, C2H6 ni adalah sebagai produk. Dekat sini dia reactant. So what happen is kita reverse. Okay, bila reverse, better you take note lah. Senang bila kita nak buat new equation lah. Bila kita reverse, so 2CO2 plus, sorry, I forgot the phrase, plus 3H2O gas equals to C2H6 gas plus 7/2 O2 gas. Okay, yang ni kita tak darab. Kenapa? Sebab kita hanya perlu reverse lah. So, bila kita reverse, when we reverse the equation, the negative will become positive. So, positive 1560 lah. Kilojoule. Okay, guys. So, let me make it bigger here. This size here. Okay. Now, let's check our equation, whether it is correct or not. So, we have 2C, we have 3H2, and we have ethane. Okay, so that is our target lah. So, kalau ikutkan, dah betul dah. Sebab dua ini adalah reactant and this is our product. Okay, cuba kita buat. Kita boleh cancel out tak? Let's try cancel out. Okay, so remember reactant and product can cancel out. So reactant, product, okay, sama. So kita boleh cancel. 3H2O, 3H2O can cancel. Okay, guys. Reactant and reactant, kita boleh tambah. Okay. And when you add 2 plus 3/2 is equivalent to 7/2. So basically we can cancel out. So yang tinggal hanyalah kenangan. Okay, I'm joking ya. So kita salin balik yang tinggal tu. 2C plus 3H2 gas equals to produk kita apa? C2H6. Okay, so delta H kita kena for delta H we have to add all of this together. So dia lagi senang lah daripada energy cycle method. Okay, bila kita tambah semua, you should get 84 kilojoule. Okay, unit dia, you follow dekat atas ni ya. So, kalau dia bagi kilojoule per mole, dekat sini kilojoule per mole lah. So, basically, this is our answer. Okay. So, this one lebih mudah lah. Okay, guys. So, let's do the second example lah. Okay, given the enthalpies of reaction, dia bagi 3 equation. Calculate enthalpy change of the reaction between carbon and hydrogen to form ethane. So, daripada ayat tu, you buat equation. Jangan pula bila dia sebut kat sini kan dia sebut hydrogen je. Ini bukan bermaksud hydrogen atom now. Ini bermaksud hydrogen gas. Okay, hydrogen dia wujud dalam keadaan gas, iaitu molekul. So, the formula is H2 lah. Kalau carbon, dia memang wujud dalam keadaan atom solid. Okay, so basically that is the equation. That is kita punya equation target. So madam dah buat dah. So kita rearrange. Okay, rearrange the equation macam tadi. Okay, so kita punya target tengok 2 carbon. 2 carbon. So sama je dekat sini. Everything we times with 2. Kenapa? Sebab kita nak 2 carbon. So 2 carbon plus 4 fluorine gas produce 2CF4 gas. Don't forget enthalpy tu kena double lah, negative 1360. Okay, that's the enthalpy. Kita darab 2. Okay, our next target is hydrogen gas. Dekat equation kedua ada hydrogen. We need 2 mole of hydrogen gas. Therefore, we times with 2. Okay, so dia akan jadi 2H2 plus 2F2 gas equals to 4HF. So, delta H dia adalah darab dengan 2 juga. So, you should get negative 1074 kilojoule. Okay, last one. Kita punya target adalah ethene. Tapi kita dah ada ethene, tak perlu darab, tak perlu bahagi. Cumanya dekat sini dia reactant, dekat sini dia product. So, kita macam tadi, sama je lebih kurang. So, kita reverse. Ingat balik dia punya rules. Bila kita reverse, sign of enthalpy also reverse. 2CF4 plus 4HF gas C2H4 gas plus 6F2 gas. So delta H sama dengan, kita dah reverse sign positive 2497 kilojoule. Okay, done. Okay, let's check. Okay, marilah kita check betul ke equation kita. Tengok target kita ada 2 carbon. We have 2H2 and we have 1 mole of C2H4. And kita try cancel out. Let's try cancel out. Okay, this one. Molekul yang sama, fluorine. So, reactant, 6 fluorine. We can cancel with this one. 4HF can cancel. 2CH4 also can cancel. Sorry. So basically that's how we check our answer lah. Okay, salin balik kita punya target tadi. Biasanya student dia punya problem adalah bila salin balik ni salah. So kena hati-hatilah. Okay, so we get our target. So, kira you should get 56 kilojoule. Okay, that's the answer lah. Okay, that's the answer. Okay guys, try do on your own. Practice question 4 ni, tolong cross out. Kenapa Madam perasan dekat sini tak sama dengan yang kat sini. Sini ada sulfur kan? Okay, kat sini tak ada sulfur. So, macam mana nak balance? Okay, so tak payah buat yang tu lah. Buat yang 3 sahaja. Okay guys, I think that's all for Hess's Law. So basically, Hess's Law ni adalah teknik untuk dapatkan enthalpy, change of enthalpy. So you kena faham Hess's Law ni maksudnya, kalau kita nak cari enthalpy of reaction, dia tak semestinya satu step. Dia boleh jadi satu step ataupun more than one step. So at the end, kalau guna step lain pun, enthalpy change dia ni sama je dengan one step punya solution. Okay, I think that's all from me. Thank you. Assalamualaikum.